Hello! Welcome to another podcast by me. So today we'll be doing a demo on Turck's RFID solution for CANOpen. Okay, let me switch my cam. Okay, over here you can see my setup. It consists of a TX700 PLC with a CANOpen module, which will be connected to our BLCCO RFID module, which processes the signal that's coming from my ultra high frequency RFID readhead. Okay, so now without further ado, okay, let me explain a bit about what goes on. Okay, before we start, let me talk a bit about the how does the CANOpen data is coming in. Okay, what is the structure? So if you control F570, okay, this is the place where the RFID module will be sending the cyclic PDOs. Okay, so right now what it will actually be, so the data will that's coming in right on the input, okay, will consist of one status message, two error code, plus 4 read byte. Okay, so do note that the RFID is only coming in, can only comes in blocks of 4. So what we'll be doing in our code will be to collect the expected level of RFID data, and you will need to stitch them together. Okay, so and then there's also another object for input where you can take 8 bytes. Okay, but this one you need to call it using the SDO. Yeah, so personally not very useful because your your RFID text right tends to have 12 bytes of of RFID EPC, so you still have to stitch it. Okay, so it will be more recommended to use the PDO and then just stitch it 3 times. So, and then similarly for the process output, it consists of 4 command, 4 byte for command, 4 byte for data. Okay, how is this? How is the structure? Well, we need to check the another manual that talks about the what's the meaning behind the command and the status bit. Okay, so let me switch to another manual. Okay, so in another manual, right? Okay, we will scroll down all the way. Okay, across all the other stuff to find out actually what's the meaning of the status bit. Okay. Oh, I think I over scrolled. Okay. Okay, if there's any doubt after the okay, after the video, right, you can actually message and ask me for the manual itself. Okay, so in this manual it actually defines the structure and the meaning of the command bit and the read data also for the BL2RFID.S. So what we have over here, right, so this BLCCO module is actually just a IP67 version of our BL20 module itself. Okay, so if you have any if you need to find any more details, you can also look for the datasheet for the BL20 2RFID-S module. Okay, it's actually the same thing, or if you already have code for that module beforehand, you can actually reuse it. Okay, so let me knock on this to show how sturdy it is. Okay, so now, okay, sorry for the distraction, back to the topic. So you can actually see that, okay, for command bit, okay, so this is the input. There will be a bit for saying that it's done, busy, error, and whether the receiver is on or off, and whether there is the tag is present or not. Okay, and from there there's only, okay, although it's written here there is 8 bytes, right, but due to the limitations of CANOpen, you can only bring in 4 bytes at a time. Okay, so if you want the full 8 bytes, especially if you're using a HF system, yeah, you can you can in fact use the the what's it called, the SDOs. So okay, and then for the process output, okay, will consist of reset bit, whether you want to read or write, or you just want the UID. Okay, so and to turn on this bit will turn on the receiver itself. Okay, so but don't worry, let me bring up my code, and then it should come in a more reader manner. So I actually already created this function block, okay, that breaks down all of the information, okay, that comes in as according for the usage for the BL20 CCO. Okay, and this is meant for actually for usage for UHF. If you want to use for HF, you might need to modify it a little bit. Okay, but it's generally a lot easier. Okay, so so let me start to run the program, and then we can see how it looks like. Okay, so as usual, we will go into the device by scanning the network, looking for whether it's there. Ayo. Okay, never connect properly. Okay, and maybe we scan again and wait for it. Okay, connect. Yes. Oh wait, no, I don't need to see the certificate. Okay, so now when I download the project, okay, I already pre-download the project into the controller, so I don't need to do too much. Okay, so for the basic step, right, what you need to do, okay, let me bring up my camera also to understand better. Okay, so over here I have a RFID UHF RFID tag. Okay, to turn on the device, to turn on to start receiving, right, turn on the XCVR bit. Okay, and you notice that the LED here, okay, starts to turn yellow. Okay, so it's working. So next I want to read the EPC. Okay, so EPC, as mentioned, we will need to tell it to read 4 bytes at a time. Okay, so we'll byte count 4. Okay, and domain over here will represent which part of the RFID memory do you want to read. Okay, so if I bring up the manual, okay, if we go to the part that's specific for UHF, you'll see that the domain area is actually classified as okay, so 0 for nothing, EPC is 1. If you want the unique ID, TID will be 2, and user area will be 3. Okay, so wait, sorry, so going back to the program, we want EPC, so your area is 1. Okay, so also for the address, right, you will need to start from 4. Okay, because the first 4 bits is actually something else. Okay, wait, actually byte count we will need to put it as 3. Okay, okay, and then address over here. Okay, so we'll go back here. So because the byte count is it's actually you have to -1 from the count that you want. Okay, so if we start the reading process, okay, wait, let me remove the tag. If you start the reading process, you'll see that the bit is busy. That when my tag goes over, okay, then you'll be done. Okay, oh sorry, let me do it again. Okay, so when you start to read, okay, when it turns on to busy, you can turn off the read bit already. So once you read the RFID tag, you'll be done. Okay, and then what is the data that comes in? You'll see that if I go to the mapping, okay, you'll see this is my RFID input. There'll be some random bunch of numbers. Okay. Maybe. Okay, let me pause the video. I will bring up the byte value as a more readable number. Okay, I'm back. Okay, so now if you just toggle the read bit, okay, you should get the first 4 bit of the address coming in. Okay, and then you just need to go through. So for example, 28226, right? If you convert 226, you'll be E2. Okay, so this is actually the first bit of my RFID block. Okay, yeah, or maybe the RFID will block E2. Okay, so you just need to repeat this process 3 more times, adding 4 address to the address each time. Okay, and then you should get okay okay you should get the same amount of data. Okay, there should not be any error when you do this. If there is error, means you're reading into the wrong places. Okay, since my tag is actually a lot bigger, 2E, the last bit is 2E, you can just quickly check 46 is 2E over here. Okay, so yeah, that is for the quick demo. Okay, however, if you just want to do it, you don't really, so that is the basic lah. If you don't really want to do too much, right? Okay, in this function block, there is a auto mode that helps you fast through the whole data. Okay, so you just tick the auto detect. Okay, and then you should be able to hold it there, and once it's done, you'll see the RFID is being fast out over here. Okay, so that is all. So maybe just to show that I did not hard code this letter in, I'm gonna put a few more other tags. Okay, put it, hold it there, and you can see that the value has changed also. Okay, or maybe something totally else. Okay, that's a okay. So that is all. Have an awesome day.